Good morning students, this is Latif sir. In this video today I will discuss about the third chapter of class 8 chemistry. The topic is elements, compounds and mixture. Elements, compounds and mixture. In class 6 we have already studied about matter. And what is matter? Matter is anything that occupies space and has mass. Okay, so anything that occupies space and has mass is termed as matter. For example, table is a matter, book is a matter, pen is a matter, air is also matter. It has some volume or it occupies some space and it has some mass also. So all these are some examples of matter. Okay, and matter is composed of any matter is composed of very small particles which are known as atoms and molecules. You know that. And molecules can exist independently while atom may or may not exist independently. Okay, so and atoms combine to form molecules. You know that, you have already studied in class 6. Okay, and on the basis of their chemical properties, chemical composition, on the basis of their chemical composition, matter can be classified in two broad categories. One is known as pure substance, another is known as impure substance or mixture. Okay, so two types of matter, pure substance and impure substance. Now see, pure substance, pure substances. What are pure substances? A pure substance is made up of only one type of atoms or molecules. A pure substance is made up of only one type of atoms or molecules, and it has a fixed composition and is uniform throughout, that is, it is homogeneous in nature. Okay, so a characteristic of pure substance, it has a fixed composition and uniform throughout, that is homogeneous in nature. And the physical and chemical properties of any pure substance remain the same irrespective of the place where it exists. The physical and chemical properties of any pure substance remain the same irrespective of the place where it exists. So now see characteristic of pure substance. Characteristic of pure substance. Characteristics of pure substances are as follows. Okay, a pure substance has definite composition. Pure substance has definite composition, and hence it can be represented by a chemical formula. For example, for example, uh, water, that means H2. In water, always two hydrogen atom and one oxygen atom is present. So the in water, the composition of hydrogens to oxygen ratio is 2:1 always. Okay, so a pure substance has a definite composition. Okay, and a pure substance can be represented by a chemical formula, like water can be represented by H2. Next point, a pure substance has specific melting and boiling point. Pure substance has specific melting and boiling point. This is the second point. Pure substance has specific or fixed melting point and boiling point, and it has a characteristic color, smell or taste. A pure substance is homogeneous in nature, always homogeneous in nature, that is, its composition remains same throughout. Next characteristic of pure substance, a pure substance has fixed chemical properties. A pure substance has fixed chemical properties. And next point, formation of pure substance involve energy, hence it cannot be separated by physical method. The components of pure substance cannot be separated by physical methods. Okay, but you can separate the components of a pure substance using chemical methods. Okay, so chemical methods are required to separate the components of a pure substance. Okay, so these are some characteristics of pure substances. And now see, pure substances can be classified as elements and compounds. Pure substances can be classified into elements and compounds. Elements are metals, non-metals and metalloids. Okay, so elements are three types: metals, non-metals and metalloid. And compounds are two types: ionic compounds or electrovalent compounds and covalent compounds. So now see, first type of pure substance is elements. First type of pure substance is elements. Okay, so a pure substance whose molecules consist of only one type of atoms are called elements. Pure substances whose molecules consist of only one type of atoms are called elements. And elements may exist as monoatomic, diatomic, triatomic and polyatomic. That is, some elements is formed by single atom, which are known as monoatomic elements, and some elements exist, or some elements are formed by combination of two atoms, and they are known as diatomic elements. Some elements formed by combination of three atoms, and they are known as triatomic elements. Okay, so elements is a pure substance. Elements is one type of pure substance which is formed by only one type of atoms, Okay, so now see types of elements: monoatomic elements, diatomic elements, triatomic elements and polyatomic elements. So monoatomic means this type of elements are formed by only one atom. For example, helium, copper, silver, carbon, neon, argon, all these are monoatomic element. Okay, and this element can exist as a single atom. That's why they are monoatomic elements. Now diatomic elements like hydrogen, oxygen, nitrogen, these elements are formed by these elements exist as a diatom, or these elements are formed by combination of two atoms. Okay, so these are diatomic elements. Okay, so some example of diatomic elements are hydrogen, oxygen, nitrogen. And triatomic elements, that is elements which is formed by combination of three atoms. Ozone, ozone is a triatomic element. Okay, ozone is an example of triatomic elements whose formula is O3. Formula of ozone is O3. Okay, so in ozone three oxygen atoms are there, so it is triatomic elements. And polyatomic elements, example of polyatomic elements: P4, that is phosphorus; S8, that is sulfur. Okay, in sulfur molecule there are total 8 sulfur atom. So phosphorus, sulfur, these are polyatomic elements. And in nature nowadays almost 118 elements are found, almost 118 elements. And out of these 118 elements, 92 elements are found naturally, and the rest of the elements are man-made elements. Okay, so and these 18 elements have been arranged in a tabular form which is known as periodic table. The elements which are found, the 118 elements which are found in nature, these 118 elements have been arranged in a tabular form which is known as periodic table. So this is the periodic table. This is the periodic table. In this tabular form, all the 118 elements are arranged according to their atomic number. Okay, and here one fact file is given: the sixth element in the last group of the periodic table. Here, this is the last group in the periodic table. There are total 18 groups. Okay, group 1 to group 18, this is group 1, and this is the last group is group 18. The vertical column vertical columns are known as groups, and there are total 18 groups, huh, and horizontal rows are known as periods in the periodic table. Okay, the sixth element present in the 18th group, that is helium. You can see there, this sixth element, helium, neon, argon, krypton, xenon and radon, this sixth element present in group 18, in last group of the modern periodic table, that is helium, neon, argon, krypton, xenon, radon. These are known as noble gases. Okay, and they are odorless, colorless, monoatomic. They are also, noble gases are monoatomic elements, and they are non-metal, and they are chemically inert. These sixth element which are present in the last group, that is group 18, and this sixth element can exist in as monoatomic elements, and they are they are chemically inactive. They do not react with any other elements. That's why they are known as inert gas or inert element or noble elements. Okay, or also called noble gases. Now see the types of elements. Depending on the properties of elements, elements are classified into three categories. Okay, metals, non-metal and metalloid. I have told before some time, elements can be classified as metals, non-metals, metals, non-metals and metalloids. So separately you have to read about the properties of metals, non-metals and metalloid. Okay, and metals are found on the left side of the periodic table. In this side, metals are present, and on the left side of the periodic table, and non-metals are found on the right side of the periodic table. Okay, in the periodic table, metals are placed on the left side of the periodic table, that is in this side, and non-metals are placed at the right, on the right side of the periodic table. Okay, and metalloid in between them. Now see properties of metal and non-metal, and here one point is given: metalloid. What are metalloids? Metalloids have properties between properties that are intermediate between metals and non-metals. Metalloids have properties that are intermediate between metals and non-metals. For example, boron, carbon, germanium, arsenic, antimony. These are some example of metalloid, and metalloid are placed here. You can see these are metalloids, example of some metalloids: boron, silicon, germanium, arsenic, antimony. Okay, so these are some example of metalloids. Metalloid have properties that are intermediate between metal and non-metal. Now see properties of metals and non-metal. You have already studied in class 6 about the properties of metals and non-metals. Okay, so you know example of example of metals. There are many example of metals like copper, iron, gold, platinum. All these are metals. And non-metals like uh, carbon, nitrogen, oxygen. All these are non-metals. Okay, so see the properties of metals. Metals are usually solid at room temperature. You know that metals are usually solid at room temperature. There are some exception also, like mercury, which is a metal but exists as liquid. Only mercury metal exists as liquid at room temperature, but all the other metals can exist in solid state. Okay, and metals, they are very hard. Metal are very hard. There are some exception also, like sodium, potassium. They are soft metal. They are soft metal. Okay, and they can be cut with a knife. And metals are usually lustrous. Okay, they are lustrous, that is shining, and they can be polished. The metals are ductile, that is they can be drawn into wires. Okay, and metals are malleable, that is they can be beaten into thin sheet. Okay, metals are malleable, that is they can be beaten into thin sheet. And metals are sonorous, that is they can produce sound. Metals are sonorous, that is produce a deep ringing sound when struck. And metals are good conductor of heat and electricity. Okay, so and metals have, as they are solid in nature, they have high melting point and boiling point. Okay, so these are some characteristic of metals. And now see some characteristic of non-metals. You know that non-metals are generally gases or liquid, but they can sometimes they are also solids. Okay, so non-metals may be solid, liquid or gases at room temperature. Maximum non-metals are gaseous or liquid, and non-metals are soft. There are some exceptions also. Diamond is a non-metal, graphite is a non-metal, but they are hard. Okay, so diamond is the hardest known substance. Okay, diamond is a non-metal, but it is the hardest known substance. Okay, and non-metals are non-lustrous and they are dull. There are some exceptions. Graphite and iodine are lustrous, although it and graphite and iodine are non-metals, but they are lustrous. Okay, and non-metals, they are non-ductile. Exception, carbon fiber are ductile. Non-metals are non-malleable or brittle. They are non-metals are brittle or non-malleable, and they are non-sonorous. They cannot produce any sound, ringing sound. Okay, and non-metals are bad conductor of heat and electricity. Non-metals are bad conductor of heat and electricity. There are some exception. Graphite. Okay, graphite is a good conductor of heat and electricity. Diamond is also very high. Diamond has very high thermal conductivity. Okay, although diamond and graphite are non-metals, graphite is a very good conductor of heat and electricity. Okay, so exceptions you have to remember, and non-metals have low melting and boiling point. Okay, so these are some characteristic or properties of non-metals and metals. Now see, second type of a pure compound is known as compound. Huh. Second type of pure substance is known as compounds. You know, elements are formed by only one type of atom, and compound is also one type of pure substance. Compounds are pure substances that are formed when two or more elements combine chemically in definite proportion. Okay, so pure substances that are formed when two or more elements combine chemically in definite proportion are called compounds. And accordingly, molecules of compound consist of two or more different type of atoms, but elements is formed by only one type of atoms. Remember that. Okay, so com, uh, molecules of compound consist of two or more different type of atoms in indefinite proportion, and the atoms in the molecule of compounds are held together by chemical bond. Okay, example of some compounds: NaCl, sodium chloride, glucose C6H12O6, water H2O, carbon dioxide CO2, limestone CaCO3. These are some example of compounds. Now see properties of compounds. A compound has unique properties that are different from the properties of its individual element. Remember this line: a compound has unique properties that are different from the properties of individual elements. That is, in water, two hydrogen atom and one oxygen atom is present, and properties of water is different from properties of its constituent elements, that is properties of hydrogen and properties of oxygen. Okay, uh, so water, for example, water is used for extinguishes fire, while hydrogen is a combustible gas and oxygen is a supporter of combustion. Okay, so properties of the compound is different from its constituent elements. Okay, remember that.